Imagine standing on a world a very, very long time from now. Not 1,000 years, not even 1,000,000. We are talking about a time so distant it makes the current age of the universe seem like a fleeting moment. Let us travel forward 100 trillion years. The year is 100 trillion. It is a number so large our minds can barely grasp its scale. The familiar star-filled night sky that has inspired poets, artists, and scientists for millennia is gone. It has faded into a profound and almost absolute darkness. The universe today is in its infancy, a vibrant and energetic place. We live in what astronomers call the stelliferous era, the age of stars. This is the time when galaxies are ablaze with light, powered by the countless nuclear furnaces we call stars. Our sun is just one of billions in the Milky Way, and our galaxy is just one of trillions in the observable universe. For now, the cosmos is a busy creative workshop. Clouds of gas and dust collapse under gravity, igniting new suns that will shine for millions or billions of years. It is a beautiful, dynamic, and wonderfully complex period in cosmic history. But this brilliant age cannot last forever. Like any fire, a star needs fuel to burn. The primary fuel for stars is hydrogen, the most abundant element in the universe. Through the process of nuclear fusion, stars convert this hydrogen into helium, releasing tremendous amounts of energy in the form of light and heat. This is what makes them shine so brightly in our sky. For a star like our sun, this process can continue for about 10 billion years. More massive stars burn through their fuel much faster, living short, spectacular lives that end in powerful supernova explosions. The stelliferous era is defined by this ongoing cycle of stellar birth and death. The problem is that the supply of hydrogen gas is finite. Every time a new star is born, some of the universe's available fuel is locked away. While massive stars recycle some of this material back into space when they die, the process is not perfectly efficient. With each new generation of stars, less and less gas is available for the next. Over immense timescales, trillions of years, the great clouds of gas and dust within galaxies will be used up. Star formation will slow down, then falter, and then eventually it will stop altogether across the entire cosmos. The universe will simply run out of the raw materials needed to build new stars. This marks the end of the stelliferous era and the beginning of a new, much darker age. The last stars to be born will be the smallest and faintest ones, the Red Dwarfs. These tiny, dim suns are incredibly efficient with their fuel. They sip their hydrogen slowly, allowing them to shine not for billions but for trillions of years. For a very long time, these faint red suns will be the only lights left in the universe. But even they will eventually die out. As the last red dwarf burns through its final reserves of fuel and fades to black, the age of stars will officially be over. With the last star extinguished, the universe enters a profound new phase known as the Degenerate Era. The galaxies we know, once brilliant islands of light, have now become galactic ghosts. The dominant objects are the stellar corpses left behind after the age of stars ended. The most common of these are the white dwarfs, the dense, Earth-sized remnants of stars like our sun. We now enter an era of such profound emptiness and longevity that it dwarfs all the ages that came before it. This is the black hole era. The Degenerate Era has passed. The only significant objects that remain are the black holes themselves, scattered across the cosmos like lonely, silent sentinels, separated by unimaginable distances that continue to grow as the universe expands. Imagine a universe where entire galaxies have been reduced to a single object. Back in the 1970s, the physicist Stephen Hawking made this truly remarkable discovery that, honestly, forever changed how we think about black holes. By weaving together the ideas of general relativity and quantum mechanics, he showed us that black holes aren't totally black after all. He predicted that, thanks to quantum effects right near the event horizon, black holes should actually emit a faint, steady stream of particles. This process is now called Hawking radiation. The evaporation of a black hole as well, a process that actually speeds up over time. In the last moments of its life, the black hole finally lets go of all its stored energy in a brilliant flash. After a Google years of darkness, the universe will, at last, see light again. These dying black holes will become the final fleeting beacons in the infinite void, temporary stars in a sky that's been empty for eons. After the last black hole has evaporated, the universe enters its final known stage, the Dark Era. This is the true end of the line. The universe is now an almost perfect vacuum, unimaginably vast, cold, and empty. The only things that remain are the leftover elementary particles. The universe has reached a state of maximum entropy. It is as disordered and simple as it can possibly be. The concept of time itself becomes difficult to define in this era. Our journey through cosmic time has taken us from the familiar star-filled skies of today to a future of unimaginable darkness and emptiness. We have witnessed the grand cosmic narrative unfold, a story not of endless light, but of a brilliant finite fire that slowly fades into embers and then eventually into nothingness. The story of the universe is one of majestic but temporary complexity. It is a tale of creation and decay, from the fiery birth of stars in swirling nebula to their quiet death as cold, dark remnants. We have traced the arc of cosmic history to its logical, albeit somber, conclusion. Reflecting on this immense cosmic timeline forces us to confront the almost impossibly fleeting nature of our own existence. All of human history, from the first stone tools to our ventures into space, has unfolded in a mere fraction of a second on the cosmic calendar. Our species, our planet, and even our sun are part of the early, brilliant morning of the universe. We are privileged to live in the stelliferous era, a time of abundant light, warmth, and the raw materials needed for life. The night sky we gaze upon, filled with constellations and the shimmering band of the Milky Way, is a special and temporary gift. As our journey concludes in the Dark Era, we are left with an image of ultimate silence. The universe becomes a near-perfect vacuum, a sea of low-energy particles drifting ever further apart. Ultimately, we are left in a state of profound wonder. We have told a story that spans not just trillions of years, but Googles, traveling from the brilliant light of creation to the absolute darkness of the end. It underscores the preciousness of our own brief sunlit existence and the remarkable power of the human mind to comprehend it all. The final fate of the universe remains the greatest mystery, a question that invites us to keep looking up, to keep wondering, and to continue our quest for knowledge on our own small temporary island in the vast cosmic ocean. The story of the universe is one of a fire that burns brightly, then slowly cools, its embers fading one by one until only the cold and the dark remain. It is a humbling perspective, reminding us of the fleeting, precious nature of our own bright moment in the cosmic timeline.